Hello everyone, today I'm going to introduce how to convert volatile fatty acids other than acetic acid to acetic acid equivalents. Why we do that? In the anaerobic digestion, we have several acids like acetic acid, propionic acid, butyric acid, isobutyric, valeric, and isovaleric acid. So when you report the data for volatile fatty acids in the digester, you have to use one common unit, which in this case, you can find it actually some literature doing it right, like to convert everything to acetic acid equivalent. So basically you use the acetic acid as the basis for calculating other volatile fatty acids to this kind of unit. How to do that? In one of the video, we converted actually organic matter to COD equivalent, and we know how to do that. For example, today I'm going to introduce this also concept to convert the VFA to COD, and regular actually or similar to what we discussed before. If we have acetic acid here plus oxygen, produce carbon dioxide and water. The same also for propionic acid, butyric acid, and valeric acid. By the way, the names for propionic acid is also, you can find it as propionic, and for valeric, it's actually also pentanoic, and for butyric, it's also butanoic. So in this case, we convert the acids to COD equivalent. Again, it's just oxidation. Every acid will be converted to carbon dioxide and water. To calculate the COD equivalent, as we mentioned before, we have to balance the equations, and based on the molecular weight, we can say, yeah, we need 2 moles of oxygen here. The 2 moles is equivalent to 64 grams, and 1 mole of acetic acid equivalent to 60 grams. So if we divide 64 by 60, we'll get the COD equivalent, which is 1.066. Similar here, this propionic acid, also the same thing. We need actually 3.5 moles of oxygen to oxidize 1 mole of propionic acid, and after calculation, we get 1.5 or 1.512 gram COD per gram of propionic acid. Here for butyric acid, the same thing. We need 5 moles of oxygen to oxidize 1 mole of butyric acid. And this finally translated into 1.816 gram COD per gram of butyric acid. Valeric acid, the same thing. We need also 6.5 moles of oxygen to oxidize 1 mole of valeric acid. For also, to calculate the end COD equivalent, we have to have 0.037 gram COD per gram acetic acid, per gram valeric acid, sorry. Okay, so in this case, what we just converted the VFA to COD equivalent. And of course, you have to also know that the isobutyric and isovaleric will be similar to butyric and valeric acid respectively, which means that if you have also isobutyric, you can actually have also a conversion factor of 1.816 gram COD per gram as isobutyric acid. And for isovaleric acid, you would actually also calculate 2.0637 gram COD per gram of isovaleric acid. Okay, so now to convert all of these volatile acids other than acetic acid to acetic acid equivalent. So for example, if we have here a concentration of propionic acid, and we have to multiply it by the COD equivalent of propionic acid divided by the COD equivalent of acetic acid. Which means that propionic acid concentration in acetic acid equivalent equal to propionic acid concentration times COD of propionic acid divided by COD equivalent of acetic acid. The same here also for butyric acid, the same thing. Butyric acid concentration in acetic acid equivalent equal to butyric acid concentration times COD of butyric acid divided by COD of acetic acid. The same here for valeric acid concentration in acetic acid equivalent, the same thing. Valeric acid times concentration times COD equivalent of valeric acid divided by COD of acetic acid. Again, this is just the equations here, and also how about the isobutyric acid and the isovaleric? Similar to what I just said, also you can actually say the isobutyric acid concentration in acetic acid equivalent is equal to isobutyric acid concentration times COD of isobutyric acid divided by COD of acetic acid. The same here, if we have isovaleric acid concentration in acetic acid equivalent equal to isovaleric acid concentration times COD of isovaleric acid divided by COD of acetic acid. Again, this is just a concentration. For example, if I have also amount, does this actually change the situation? No, because basically we'll have also, if we have 1 gram of butyric acid, I would like to convert this 1 gram as a mass to equivalent of acetic acid, the same thing, except that I will not actually have concentrations here. I will have the amount. So basically, if I have amount of butyric acid, 1 gram of butyric acid, I would like to convert it to acetic acid equivalent. So in this case, it will be the amount that is 1 gram times the conversion or the equivalent of COD of butyric acid divided by acetic acid. Okay. So basically, this is I just said. So this is just summarizing what I said in the last slide. So here we will have the propionic acid concentration in acetic acid equivalent. It will be propionic acid concentration times 1.418. And also, again, if you have amount, not a concentration, so you need to multiply the amount here. So the amount of propionic acid, for example, times 1.418 to get you the amount of propionic acid in acetic acid equivalent. The same also for butyric acid. So butyric acid concentration in acetic acid equivalent is equal to butyric acid concentration times 1.74. And of course, here, the valeric acid concentration also will be valeric acid concentration times 1.9. So basically here you would actually expect that this also, I think this is just typo here. So you need actually to see that valeric acid concentration in acetic acid equivalent is equal to valeric acid concentration times 1.11, which is this amount. So basically the concentration of valeric acid is missing here. So basically this is not really right. So you need actually to multiply this number by the concentration of valeric acid concentration. Of course, this is the table, just conversion. Of course, gram acid of acid for acetic acid, this should be 1 because basically acetic acid is acetic acid, no conversion in this case. So let's go to this example here. The concentration of volatile fatty acid in a reactor are shown in this table, and you may find actually some people just sum all of this and get you this number. So based on this, I would say this is actually wrong, right? This is basically wrong. Why it's wrong? Because basically here, what is actually here is just a summation of acetic acid, propionic, isobutyric, butyric, valeric acid. So this is actually, it's not really right to just summarize, to sum all of this concentration and say the total volatile fatty acid is 11 point whatever actual number. This is not correct because, again, this is different acids, and we have to be careful in when actually converting or reporting the value. So basically, we have to calculate the total in of VFA in acetic acid equivalent. To do this, the same thing actually, just basically what we have said. We have actually the conversion factor between different acids and acetic acid. So basically, gram acid per gram acetic acid. So basically, here this is 1, as I mentioned. And for propionic acid, we'll have 1.42, and for isobutyric acid 1.7, butyric acid the same thing, and isovaleric acid 1.19, 1.91, and for valeric acid, we'll have 1.91. Okay, so basically this is the conversion factor, and we know from where did we get this numbers based on the COD and this explanations that I just said. So in this case, just multiply the concentrations that you have in the reactor by this number, you get actually the acetic acid per liter. So basically this acetic acid equivalent in this case. So basically here, we converted this basically here, this will be the acetic acid equivalent. So basically here, this is acetic acid equivalent here, equivalent. So not actually acetic acid, but this acetic acid equivalent, which means that we have 2.68 gram of acetic acid that is equivalent to the 1.9 of 1.89 gram of propionic acid in this case. Okay, so basically if you look at these numbers here, so completely different, right? So basically this is the summation. If we as we mentioned in the previous slides, that this is actually wrong actually to do that. This is actually wrong, is that you can report just different acids in the same, because they are actually different molecular weight and different COD needed to oxidize this. So basically this is the correct way. So the correct way is that we can say the total VFA in this reactor is 17.55 gram acetic acid equivalent per liter. Okay, so I hope actually this is useful. And